So here's what we're going to do. This is the ice to water to steam lab. This is going to take almost a half an hour, and you should be able to keep track of that with the clock that's on the wall. That's kind of why I set this up here. I have a hot plate that I'm going to turn on in a little bit. There's a beaker filled with ice, and there's a thermometer. And you can see the temperature through the thermometer. We are going to be tracking the temperature and making observations for the next half hour. So let me get my stopwatch. And it is 10:31 on the clock. We are going to start now. I'm turning the stove on as high as I can, and we're going to let it go for the next 30 minutes. All right, and I will be counting off the minutes so that we can keep track of all the time that goes by. Before you watch this video, you should have already written down your data table from this activity 3.14, because as we go through, minute 0 is at 1 degree Celsius according to the thermometer. It's right there just above the 0. And we're coming up on one minute, right? Now, and the temperature is 0 degrees Celsius. So it actually got colder, because what's happening is the heat from the oven is melting the ice, and that's decreasing the temperature. So we might see the temperature stay low until the ice is melted. You can see that there's water in here, but that it's filled all the way to the top with ice. So in the observation column, you're going to write down the container is filled over the top with ice. We're at 1:30 now. Coming up on 2 minutes in about 10 more seconds. And we're at 2 minutes now. The temperature is, again, 0 degrees Celsius. This is getting really hot. I can't touch that with my hand. And the ice is melting, but there's still ice in the beaker. It's still going, and so we're just going to keep going. So for observations at the end of 2 minutes, ice is still at the top of the beaker. We're at 2 minutes 30. I can see the ice is starting to shift a little bit as it warms up. We're at 3 minutes now. The temperature is 0 degrees Celsius. All right, the ice is looking like it's beginning to melt, but again, the ice is still up over the top. It shifted a little bit and lowered a little bit, but 3 minutes have gone by and there is still a lot of ice in that container. You can see, though, that the level of water has changed. If you go back and you watch earlier in the video, that water level will probably be a little bit lower, because as the ice melts, it's going to add to the volume of water. We've got about 15 more seconds before we get to 4 minutes. There goes the shifting, and that is 4 minutes, and the temperature is, look at that, it is at 6 degrees Celsius. So the temperature is going up a little bit, but again, there's still ice in the container. Turn that so that maybe we can see it a little better. So the ice is no longer above the top of the container. That's how much has melted. So in your observations for 4 minutes, you're going to write that the ice is now lower than the top of the container. More seconds, and we're coming up on 5 minutes. And mark, we are at 5 degrees Celsius at 5 minutes. The ice is now lower than the top, and it is still melting. And look, the water level is up where this bar is now. The bar is there to help make sure that the beaker doesn't fall off if somebody bumps the table, but you can see the water level is there now. So again, it is higher. We're at 5 minutes and 30 seconds. Like I said, this is going to be a long video. Ten seconds left until 6 minutes. And 6 minutes, and we are at 6 degrees Celsius. The ice has now melted so that it is even with the level of the water. Maybe just a little tiny bit above, but the ice is now about an inch below the lid of below the rim of the beaker. So for observations, you're going to write some of those things at the 6 minute mark. Six minutes and 30 seconds. Ten more seconds, and we're coming up on 7 minutes that this has been going on. Mark, we're at 7 minutes. The temperature is now at 10 degrees Celsius. So it's still really cold. Like I can put my finger in there. The ice is no longer touching the bottom. It is freely floating in the water. That is the observation you're going to write down for 7 minutes, that the ice is freely floating. It's not touching the bottom. It is like a glass of ice water freely floating in there. 7 minutes, 30 seconds. You can see that the temperature is dropping a little bit. It was at 10, I believe. We have about 5 more seconds before I do a temperature reading. So at the 8 minute mark, the temperature is up, it's back up to 10. It had dropped down to 8 briefly, and then now it's back up to 10. Looks like the ice is, again, quickly melting. But you know, as long as there's ice in there, the temperature is not going to do anything really drastic. It's going to, all of the energy is going into melting that container of ice. Once the ice is melted, you're going to see the temperature start to climb. 7 minutes and 30 seconds. Sorry, 8 minutes. 8 minutes and 30 seconds. Ten more seconds. We're coming up on 9 minutes. And mark, the temperature is 12 degrees Celsius at the 9 minute mark. The ice is only about 30% of the top of the container. There's 2/3 or 60% of the bottom, of the bottom is just water. All right, so there's only a tiny bit of ice left, but still, the temperature is holding on at right around the 10-degree mark. We are at 9 minutes and 30 seconds. This has been cooking now for almost 10 full minutes, and the temperature is still pretty cold. Like, I can put my finger in there. It is not warm. It is actually cold. It's chilly. We are at 10 minutes now, and at the 10-minute mark, the temperature is 13 degrees Celsius. I move it down a little bit so that I can see it, because this bar that's holding the thermometer, it gets in the way, so I can shift it up and down as long as that red bulb stays in the water. There is barely any ice left, just at the very top, so that's going to be your observation for the 10-minute mark. Minutes and 35 seconds. And coming up on 10 minutes. Mark, the temperature is 17 degrees Celsius. The ice is just at the top, and it's only covering half of the top. So I highly anticipate that by the next time we take the temperature, the ice will be completely gone. But you can barely see any ice in there, and the water level is up at the, let's turn this so that we can see. The water level is at the 450 milliliter mark. 10 minutes and 35 seconds. No, 11 minutes and 35 seconds. Sorry. I'm trying to read this little inner wheel and the arm was in the way. So we're coming up on 12 minutes. And Mark, the temperature is 21 degrees Celsius, and I see one little teeny tiny bit of ice left. All the rest of the ice is gone. So the ice has completely melted, and the temperature is climbing. It was at 21 20 seconds ago, and it's already starting to move a little bit faster. So keep in mind that for the last 12 minutes, it's pretty much hovered between 0 and 20. And I want you to watch what happens on your charts, and then later on your graphs over the next maybe 5 minutes, what happens to the temperature. 20 seconds left. 15. 10. 5. We're coming up on 13 minutes. Mark, that is 30 degrees, 29 degrees Celsius. So it went up 8 degrees in 1 minute. That is the biggest jump yet. All of the ice is gone now. There is just water in the beaker. And I don't know if you can see it on the camera, but there are little bits of, I don't know what that is that was in the ice, maybe dust or something, that are floating in there, and they're moving up and down and up and down. That's convection currents. 30 seconds, 35 seconds. We're coming up on the 14-minute mark. Mark, we are at 36 degrees Celsius. So another jump. This one only about 7 degrees, maybe 8 degrees. But it jumped from the previous time. It's warming up a lot faster now than it did when there was ice in the container. Minutes and 30 seconds. Again, if you're keeping track on the wall clock, we should be at the same amount of time. We should be 14 minutes from when it started. So I believe it started at 31 or 32. Oh no, 15 minutes. We're coming up on 15 minutes. Mark, and that's 42. It is just water now. Pretty much the same observations. There's little particles suspended in the water that are moving up and down with convection. As the water heats up at the bottom, it rises, and then when it gets to the top where it's cooler, it becomes more dense and sinks. And it's just doing this circular pattern. 15:30. Minutes, the temperature is 49 degrees Celsius. Same observation as 14 and 15. I do not see any steam or bubbles yet. That'll be the next thing that we're looking for, is whenever we spot steam coming off the top and bubbles forming in the liquid. Another 20 seconds, and we'll be at 17 minutes. Right there, we're at 55 degrees Celsius. Water's getting pretty warm now. I think I can see barely little tiny bits of steam, but the steam's going to start more vigorously, and you'll actually be able to see it on the camera. It's still a little early. We are coming up on 18 minutes. If I'm wrong on my minutes, I'm going by the little wheel in the middle, but just keep track but I believe this is coming up on 18 minutes. And right there, temperature is 61 degrees Celsius. Occasionally I can see the edge of the beaker get like a condensation or like a steaminess to it, but again, it's not really noticeable. It might be difficult for you to see it on the camera, but as the temperature gets closer to 100, you're going to see more and more steam, more and more bubbles. I can see a single bubble forming on the bottom, and you may be able to see the convection currents in the water as well. 20 seconds away, and we'll do our 19-minute reading. Right there, we are at 67 degrees Celsius. I can see steam now at the top. You can it on the side here. That's why it's discolored here, because it's cooler on the outside, so it's condensing. But there is steam present. And there's still that one bubble right at the bottom. Some little bubbles starting to form on the side. In about 20 seconds, we will have been going at this for 20 full minutes. This is, like I said, it's going to be a long video. Time, it is 72 degrees Celsius. I can see steam really well now. And there are lots of bubbles that have formed at the bottom, and occasionally one of them will release and rise. So watch for that. There's one that just formed right there between the 300 and the 200. I have to be careful not to touch this now, because now the container is hot. You can tell that because the temperature is 74 degrees Celsius. Don't write that one down. We're 20 minutes and 40 seconds, so we still have 20 seconds left before we write down the temperature. Mark, the temperature is 77 degrees Celsius at the 21-minute mark. Now I'm starting to see bubbling inside. It's a little bit of bubbling. We have about 20 more seconds before we do 22 minutes. Maybe on the camera you can see some of those particles moving now, because they're moving a lot faster with the bubbling. And there is 82 degrees at the 22-minute mark. You can start to see lots of bubbles, not a lot of bubbles, but you can start to see bubbles coming more regularly off the bottom. We're getting close to the mid-90s, which is when you should see what's called a rapid boil. If you do any kind of cooking, a rapid boil is when there's lots of vigorous bubbling going on. But there is lots of steam, and there are bubbles forming at the bottom and coming up at a rate of about 1 a second. We're coming up on 23 minutes. Right now, and the temperature is 86 degrees Celsius. Lots of steam now. Again, lots of little bubbles forming in, but lots of bigger bubbles starting to appear as well. We're about 30 seconds away from 24 minutes. This is, again, has been a very long video. In fact, I think whenever I post it, I might split it into 3 pieces. That way, no piece is going to be longer than about 10 minutes. About 5 seconds away from 24 minutes. Right there, it is 91 degrees Celsius. Lots of steam, lots of bubbles. This is what's called a slow boil. It's just beneath full boil. You get like a little bit of bubbling. Seconds. Coming up on 25 minutes in a little bit. Now, 25 minutes, it is 95 degrees Celsius. You should see bubbling going on. So write down that there are lots of little bubbles and then some medium-sized bubbles as well. Seconds away, and it will be 26 minutes soon. And coming up on time, it is at 98 degrees. That is a rapid boil. All right, so that is a very vigorous boil, lots of bubbles, lots of steam. Coming up on 27 minutes. The temperature is 100 degrees Celsius. It is at exactly 100. Now, in order to track what happens, because remember, at the very beginning, it stayed flat while there was ice in there. I'm going to leave it go for 5 minutes to see if the temperature changes. That way we have data on our chart and on our graph showing the temperature that occurred 5 minutes after we achieved a full boil. So that means 27 was a full boil. That means we're going to go to 32. So on your data chart, you need to have it up to 32. 15 seconds away from 1 minute at boil. That's 28 minutes. It's still at 100. It's holding steady. It is rapidly boiling at 100 degrees Celsius. You guys should be glad I did not make you do this lab, because we would be sitting here for 32 minutes recording the temperature of water as it boils. We're coming up on 29? Yeah, because the previous one was 20. 29 minutes. This is 2 minutes worth of boiling. We're still going to go mark. That's 100 degrees Celsius still. It has not changed. Keep in mind, we are still going to go for 3 more minutes. I just want to see if the temperature will change. It has not. For the past 2 minutes, it has remain steady at 100 degrees. The container is boiling away, and water is converting from liquid into a gas. So this gas that's escaping, the steam, used to be solid ice about 30 minutes ago, 29 minutes ago, it was solid ice. And now the particles have been given so much energy that they've gone from liquid to now a gas, and they are escaping into the atmosphere. And as I talk to you, I am breathing in some of those particles that 29 minutes ago were ice. 5 seconds, and we are at 30 minutes. We are still at 100 degrees Celsius. I'm going to go for 2 more minutes. I can do it. I hope you can too. The difference is you could always hit pause and come back to 32 minutes or the last 2 minutes. I cannot do that. I have to sit here for the full 32 minutes and hold this stopwatch and talk to you and make it sound interesting. And now I'm starting to realize how difficult it would have been if I were a radio voice talking on the radio, because I have been talking to you now for 32 minutes trying to fill up the emptiness and not doing a very good job, because there are lots of moments on this where it's just me holding the stopwatch and not talking. Although for this minute, I'm trying to fill up the entire minute with the sound of my voice. It's probably not going to happen. I only have 10 more seconds left though, so let's see if I can do it. I'm not exactly sure if I'm going to be able to, because I have 5 more seconds, and I need to look at the temperature because time, it is 100 degrees Celsius. We have 1 more minute left to go. I am so happy. I hope you are too, because this means that we're getting ready to come up on our last data point, and since it hasn't changed in the last 4 minutes, I would be highly surprised if it changed in the next 1 minute. You never know though, that's why we're doing this. It's science. You collect a lot of data, and then you analyze the data in a graph just to see if there's any kind of pattern that goes on. And that's actually what you're going to do at the end of this video, is you're going to take all of that data and you're going to make yourself a nice little line graph that shows all of the information on an easy to read chart, so that you can see all the areas where the temperature remains steady and flat, like at the beginning and here at the end, and all of those times when the temperature shot up, like when there was just water in there and the water was rapidly increasing in temperature. And here we go at 32 minutes. We are at 100 degrees Celsius. I'm going to reach over and turn this off, and I'm going to stop my stopwatch, and I'm going to pause the video in a little bit. So at this point, ladies and gentlemen, what you need to do is you're going to finish your data table, and then you're going to draw your graph. If need be, you can go onto a different sheet of paper, or you can turn the page in your notebook, but you do need to have the data table in your notebook and the graph. There is a blank graph below the data table on 3.14. In addition to that, if you go below the graph, there are some conclusion questions that I need you to write in your notebook. All right? That is me signing off. This is actually going to take up 2 days, so you have Monday to work on the beginning of this, and then you'll get a little time on Tuesday to work on it and to do the graph. And then when I come back on Wednesday, yay, September 18th, I will see all of you, and we will go over the information and record. But this is me saying I'm very tired of sitting here talking about temperature.